Hello, algebra students. Mr. Laurence here, and this video is for everybody that wasn't in a Delta group after the cluster, the little formative assessment we took. Those of you who aced the little formative, then you can turn this off. You're welcome to watch, but you don't have to. You can take a little break tonight. All right, so first of all, I'm going to do two types of problems. I'm going to do powers raised to powers and undistributing. Now, those of you still having trouble, you can always go back and watch a previous video. All right, well, first of all, I'm going to cube everything. I'm going to raise everything to the third power. Now, if you want, you could write it out like this. You could go, well, 5x to the 7th y squared times 5x to the 7th y squared times 5x to the 7th y squared. Right? This is an exponent problem, and I just changed it into a multiplication problem, right? We don't want to think about this as multiplication. This is an exponent problem because that exponent, power raised to a power. Now, if I do that, I just multiply 5 times 5 times 5, and I get 125. X to the 7th, x to the 7th is x to the 14th, times x to the 7th would be x to the 21st. And then y squared times y squared times y squared would be y to the 6th, because I would have 6 y's being multiplied. I know I'm going a little bit fast, but this is, this third or fourth time I've put this in a video. So you need to be checking out what's going on, coming to see me if you're not getting it, and thinking about the math, not just on the video, not just in the classroom, but think about it a little bit while you're eating breakfast. Think about it a little bit before you go to sleep. Just a little bit. Just think about the things we did in class today. Kind of mentally review. That will help your understanding. All right. Now, I could have done it much more quickly. I could have said this part here would be x to the 21st. Right off the bat, I could have gone 7 times 3. That's a shortcut. I don't like the shortcuts, but they are true and they do work. Y squared times raised to the power of 3 would be y to the 6th. And then, of course, I have to do 5. And if you want 5 to the 1st, 1 times 3 would be 5 to the 3rd. But then I have to evaluate that to get 125. Now, I said I don't like the shortcut. I don't like it when you don't understand why you're doing it. It's really important if you have a really bizarre problem. Like if you had, say, x to the 5th to the 1,000th power. Well, I tell you, there's no way I'm writing out 1,000 of x to the 5th. I'm just going to use the shortcut and go x to the 5,000th power. Okay, so the shortcut has its place, but we have to understand why we're doing it. All right, so that being said, let's check this one out. It would be 7x y to the 9th z to the 8th times the quantity of 7x y to the 9th z to the 8th. How did I know to write it twice? Because there's a 2 here. That exponent, that power, means there are 2 of those groups or quantities. Just multiply your 7s. 49 x times x is x squared. Y to the 9th times y to the 9th would be y to the 18th. Z to the 8th times z to the 8th would be z to the 16th. Now, some of you using the shortcut will get the wrong answer. Some of you using the shortcut will get 49x y to the 18th z to the 16th. If that's you, if you're a person who is wondering where this x squared came from or know you would miss it, please, when you don't see an exponent, put a little 1 there. And then you can multiply the 1 times the 2, and sure enough, you will get x squared. All right, we're going to do 2 on distribution problems. The first thing I do is I go and find the GCF. I need the GCF of the 12 and 24. Well, if I list the factors of 12, I get 1 and 12. I get 2 and 6, and then 3 and 4. All right, now, I ask myself, does 12 go into 24 evenly? It sure does. 12 is a part of my GCF. Now I need the GCF of x to the 4th and x squared. Well, what's the greatest number of x's that both sides have being multiplied together? It would be 2, right? X times x. And you could say, hey, x times x times x times x. There's 2 of them here and there's 2 of them there. Therefore, x times x is a common factor. I don't want to say x times x, I'm going to say x squared. So my GCF is x squared. All right, so now, let me get a bigger eraser here. All right. Oh no, I just changed my GCF accidentally. Sorry about that. All right, so I'm going to divide both of these terms by the GCF, both of them. Okay, now when I do that, the GCF comes out front because I'm undistributing. 24 divided by 12 is 2. X to the 4th divided by x squared is x squared. All right, 12 divided by 12 is 1. Let's cancel. X squared divided by x squared cancels, I get a 1. Now be careful here. I see too many people, for some reason, putting a multiplication symbol here. No, it was a subtraction problem, right? It needs to stay a subtraction problem inside the quantity. By the way, this is done. There's nothing else you can do with this problem as it is written. All right, so let's try this again. I've got this big, long, ugly one. I wonder if I can move it. Well, I can move part of it. All right, I'm going GCF hunting, right? Going to look for my GCF. All right, well, I need the GCF of 36 and 27. So I'll list the factors of 27. 2 doesn't go in evenly. 3 does 9 times. I got to check 4, no. 5 doesn't. 6 doesn't go in. 7 doesn't go in. 8 doesn't go in. I'm back to 9. I'm done. Okay, so does 27 go into 36 evenly? No, it does not. Does 9 go into 36 evenly? It sure does. 4 times, right? So part of my GCF is 9. Now looking at my x's, I've got x to the 7th and an x to the 8th. This side has 7 x's being multiplied. This side has 8. How many do they have in common? Well, of course, the answer is 7. X to the 7th. There are 7 x's being multiplied on both sides. This one has 8, but before you can have 8, don't you have to have 7? All right. Now I look at my y's. All right, on this side I've got 5 y's being multiplied, and here I've got 2 y's being multiplied. They must have 2 that are in common. There's my GCF. So I'm going to divide by the GCF under both terms. Okay, the GCF comes out front when I do that. I'm actually undistributing here. We're actually going to call it factoring soon, but for right now, undistributing works really well. 36 divided by 9 is 4. X to the 7th will cancel. Y to the 5th over y squared. I think that'll be a y to the cubed. Y cubed. All right, now notice I don't put the multiplication symbol in there. See my subtraction sign? I need it. 27 divided by 9 is 3. X to the 8th over x to the 7th. Well, that'll be x. Y squareds cancel, and there you go. All right, there is a video quiz. Now, here's what's going to happen. The people who didn't have to watch the video are going to turn in a slip saying I was a delta. Put their name on it and say I was a delta. If you lie about it, I will know, and you'll get a 0 and probably a call home because I already have the deltas recorded in my grade book. So, anyway, here's 2 problems for you to practice on. That's it for the video. Mr. Laurence signing off. Have a good night, everybody.